So our next speaker is Ashley Pries. Ashley joined the MAS MBC program at Scripps to transition from a career in health and human services to a career in marine conservation. This was a dream that had lingered ever since her internship fresh out of college when she worked at a wildlife center rehabilitating elephant seals. Ashley's background is in nonprofit management. Before joining the MAS MBC program, she worked as a grant writer and fundraiser at one of the 10 largest nonprofit organizations in Orange County, where she also managed volunteers and ran its youth volunteer program. She loves learning about seaweed, and she volunteered with the Smith Lab at Scripps, helping with their seaweed herbarium collection. Ashley is happiest when she is in the ocean, any way she can be. And the title of her presentation today is A Little Bit of Sargassum Goes a Long Way: Observations and Mapping of Sargassum from NOAA Ship Okeanos Explorers ROV Deep.
Thank you, Samantha. The picture book I Spy was always one of my favorite ways to pass my time in the occasional waiting room that happened to host it. One of the reasons why it was so fun is because this book was interactive. The stakes were different from other books. There was a game and a challenge involved with each turn of the page. There is a lot to look at in these books, but each discovery of one of the sought-after objects would be accompanied by a self-congratulatory tingle of pride. But with each eventual revisiting of these I Spy books, the pages would lose some of the glimmer of their original mystery. Flipping through the now familiar pages, I would be disheartened to realize that the objects had been found, the scenes had become stale. Rather than a process of curiosity, exploration, and discovery, the rereading of these books had turned into a dull exercise in memory and recall. Now imagine a game of I Spy where the scenes are limitless, and each page you look at is one of the least explored habitats on Earth. In fact, no humans have set eyes on that place before. The setting is the deep ocean, which is often considered to be 200 meters and below. Deeper than 200 meters, light essentially disappears, water temperatures approach freezing, and the pressure becomes crushing. Even in this environment, though, deep-sea habitats can hold a high abundance and diversity of organisms. But because of the logistical challenges of accessing the deep sea, it remains one of the least understood ecosystems on Earth. In this I Spy challenge, the stakes include a variety of environmental and ecological factors related to climate change, food web dynamics, and habitat protection. Because if we can make observations in situ, or in the actual environment, we can shine light on the relationships between the distribution of organisms and differences in the environment. That's what I got to do for my capstone project. For the past 10 weeks, I've been engaged in my own game of I Spy, reviewing video recorded by NOAA ship Okeanos Explorers Remotely Operated Vehicle, or ROV, Deep Discoverer during NOAA's Office of Exploration and Research's expeditions to explore the deep sea. What I was looking for was a type of seaweed called sargassum. Sargassum is a genus of brown algae, or seaweed, that can be found in most of the world's oceans. In the areas I looked at for my project, off southeastern United States and in the Caribbean and in the Gulf of Mexico, there are two sargassum species, Sargassum fluitans and Sargassum natans. Both of these species are holopelagic, meaning that they do not grow attached to a substrate and are unique in that they are completely free-floating. Whereas most seaweed needs to grow attached to the bottom, these two sargassum species instead grow floating on the ocean surface and can remain in the open ocean throughout their entire life cycle. The sargassum is kept afloat at the sea surface by small, round, gas-filled bladders that grow along the stem of the algal body. In the Atlantic Ocean, wind and currents in the slowly spinning Sargasso Sea concentrate this floating sargassum into large rafts. These sargassum rafts form the basis of a unique high seas community, providing an ecologically important habitat to fish and invertebrates. Since 2011, giant sargassum blooms have also been observed stretching from the west coast of Africa to the Gulf of Mexico. This constitutes the largest macroalgae bloom that has ever been recorded. And following periods of high productivity, tons of sargassum have been washing up in recent years in beaches in the Gulf of Mexico and in the Caribbean, which has had a devastating impact on tourism as well as impacting the coastal ecology. Now, there's a lot of effort to document sargassum on the surface using aerial observations and satellite imagery, but the sargassum can also sink below the ocean surface when its air bladders degrade, such as when it is being eaten or after it has perished. I'm interested in what happens to the sargassum below the ocean surface. One of the reasons why I chose to look at sargassum is because of the vast quantities of photosynthetic material on the surface many, many miles offshore that are very likely ending up in the deep sea. This may have important implications for the sargassum's role as a carbon sink. Through photosynthesis, sargassum converts sunlight, carbon dioxide, and ocean nutrients into sugars and other carbon compounds. This organic material and the carbon it contains can then end up on a number of different pathways, such as washing up on beaches, being eaten by a consumer, or sinking into the bottom of the sea. Once it ends up in deep ocean currents or in seafloor sediments hundreds of meters below the surface, the carbon is prevented from being exchanged with the atmosphere over extended time scales, over several hundred to several thousand years. Carbon dioxide in the atmosphere is a greenhouse gas that absorbs and radiates heat, and increased levels of carbon dioxide have been linked to increasing impacts of climate change. So removing carbon dioxide from the atmosphere is a good thing. Which is why I chose to look at sargassum, which is where my game of I Spy comes in. Earlier, I showed this clip taken from the ROV Deep Discoverer showing this beautiful black coral covered in fly-trap anemones as squat lobsters hang on for dear life to avoid being swept away by the current. What you probably did not notice is this small brown clump on the bottom that is actually sargassum seaweed. If we can better understand how much sargassum is reaching the deep sea floor and in what areas, we can better understand its ecological and environmental roles, such as its potential for a carbon sink. So I reviewed ROV footage from 3 areas where high quantities of sargassum have been reported washing ashore: the Gulf of Mexico, off the southeastern United States, and in the Caribbean, to see if sargassum was also appearing on the seafloor. My first step was to look at ROV footage like this from NOAA's Office of Ocean Exploration and Research, Okeanos Explorer Deep Sea Expeditions. I watched 50 hours of video from 6 dives using Situ, a video playback and annotation tool created by Ocean Networks Canada for deep ocean exploration. The ROV is equipped with high-definition cameras that enable really beautiful imagery, and this part was a lot of fun because while the dive is taking place, it's also being narrated by scientists. So I got to listen into this exploration and join in as if I was joining in real time. I would watch the video and hope to see sargassum appearing on the screen. And after some time, I got better at recognizing what could be sargassum based on its color, shape, and movement. If I saw something that looked like it might be sargassum, but I wasn't sure, I would look at higher resolution video of that moment in case better image quality could help make the identification. A lot of this time was spent wishing the camera to change its angle or zoom in a little more to allow me to make a positive identification. And it was a really satisfying feeling to have sargassum come into view. The cameras are equipped with a zoom that allows really detailed imagery of an object far away. And even though they were usually zooming in on things like coral polyps, I could often identify sargassum in the foreground or in the background during these zoomed in moments. Now I have become so accustomed to spotting sargassum that there have been several times when a small shrub that slightly resembles sargassum appears on the screen. My eyes will zero in on it, and I need to overcome the instinct to pause what I'm watching and make an annotation. The second part of my project was entering annotations into Situ. Each time I observed sargassum, I would pause the video I was reviewing and enter an annotation identifying it to the sargassum genus. These annotations also capture the sensor readings at the time the annotation was made. Once an annotation is archived, it can be viewed and searched for by other users. I next downloaded and processed data from the dives. Both ROVs on board Okeanos Explorer are equipped with CTD sensors, which measure conductivity, which is a proxy for salinity, temperature, and pressure, which is a proxy for depth. I used a data conversion software to convert the raw data from these sensors into a format that could be used in ArcGIS Pro, which is a program used to store, visualize, and analyze data. And this is an image of one of the ROVs being deployed from the bow of Okeanos Explorer. I then used ArcGIS Pro to map the Sargassum observations and analyze the CTD data collected by the ROVs during the 6 dives. This is one of the maps I made. It's of a dive in the Gulf of Mexico that also shows the highest number of Sargassum observations. The green line shows the dive track that was recorded by the ROV, and the red circles show the Sargassum observations. And this dive was approximately 1,000 meters deep, and there were 30 instances of Sargassum observed. And these are all 6 of the dive sites and the number of Sargassum observations for each dive. I was really excited to observe Sargassum on each of the dives, with observations ranging from 6 to 30 per dive. This indicates that Sargassum is reaching the seafloor in potentially significant amounts. Sargassum was observed in several conditions in a range of different environments, from a rocky feature at the base of a steep wall, to varying levels of sediment, to brine pools, to coral mounds. Because these are places that have never been described before, any observations or site characterizations can lend valuable insight into the dynamics of that deep sea community. It may allow us to better understand how a changing climate may affect and be affected by this carbon sequestration process. This may have implications for management and climate adaptability. And one thing that I want to mention that is perhaps the most thrilling part of this version of iSpy is that it is not a solo game. Okeanos Explorer is enabled with telepresence to connect a few scientists on board to dozens of scientists on shore through live video streaming, chat rooms, and conference calling. You are joined by a crew of scientists and specialists who are following along in real time on land to share in the discovery, marvel at never-before-seen biology, and lend their expertise to these fact-finding missions. The sense of excitement and promise of discovery is palpable in this community of deep sea enthusiasts. Data collected on the ship follow federal open access data standards and is publicly available shortly after an expedition ends. This ensures the delivery of reliable scientific data needed to identify, understand, and manage key elements of the ocean to anyone that needs it. Like a cutting-edge version of the iSpy books always being available at the public library, all of the video and data from these NOAA ocean exploration and research expeditions are freely and publicly available, ready to inspire a new wave of iSpy ocean adventurers. Thank you. All right, happy to take questions.
Great, thank you, Ashley. So do scientists have an idea as to how much carbon is being sequestered as sargassum in the deep sea?
They have a preliminary idea. There was a study done a couple of years ago looking at all macroalgae, so seaweed that includes things like kelp as well as sargassum, and that determined that approximately 190 million tons of carbon could be sequestered by all of this macroalgae seaweed. Of that 190 tons, approximately 90% of it is thought to be sequestered to the deep ocean. And that turns out to about the total carbon emissions of the state of New York. So that's the only estimate that I could find. It does look like that there needs to be much more additional study in order to reach a more conclusive measure.
Great, and you must have seen a lot of really wild things in combing through all that footage. What was the most interesting thing that you saw in the ROV video?
The ROV video was really, really beautiful, and it's hard to choose what would be the most interesting thing that I saw. On one of the dives in the Gulf of Mexico, about 250 kilometers south of Louisiana, there was a really interesting habitat that was it was like a brine pool. So instead of being like the normal density of the water, the brine pool was a much more dense, and so you could see the difference between the darker, dense water versus the other water above it. And so it was just a really beautiful, kind of otherworldly environment. And I want to mention also, in that dive, there were several sightings of debris from the surface. So that was unfortunate, although it was a beautiful setting, there were some debris that were spotted.
Interesting. Thank you so much, Ashley.